audible? Okay, test tomorrow. No, I'm not conducting test this week. I'll conduct the test on next Saturday. Fine, Anushka?
Yes, ma'am. Thank you, ma'am.
Okay. But next Saturday, complete test of EMI, the whole lesson. So let's
Yes, ma'am.
complete induction today. Induction is only left. Tomorrow we'll start with AC. Then next weekend you can have a complete class test of EMI. Now, see self-induction. Induction means what? We have till now studied so many things in EMI. Emotional EMF also we have completed. So we had studied that whenever there was main thing, the basic thing in this lesson was what? Whenever there was a decrease or increase in the magnetic field, there was increase or decrease in the magnetic flux because of magnetic field. And as there was a change in this magnetic flux, there was what? An EMF induced in it and also a current induced. These two things were induced because of the change in the magnetic flux. Fine. So this induced EMF, we call this as induced EMF because this EMF has been induced because of the change in magnetic flux, right? So now we'll use, when we use the term induction, this is the exact term induction that we have studied for inducing EMF. Induction means inducing EMF or inducing current. This induction means what? Inducing EMF or inducing current. So when a current flows in a coil, it gives rise to a magnetic flux through the coil itself. Now, as the strength of the coil changes, this is your coil. Fine. So let's say current is flowing in this coil. Some current is flowing in this coil. So as the current is flowing in this coil, what will happen? There will be a change in the magnetic flux within this coil. Magnetic flux will either decrease or magnetic flux will increase. Either of these things can happen depending upon the magnitude of magnetic field, whether it's increasing or decreasing. Now, as there is magnetic flux changing, see, an EMF is induced, but within the same coil only. In this coil, current got changed, magnetic field increased or decreased, flux increased or decreased, and EMF also got induced in the same coil. So this is known as self-induction. If within the same coil, this same coil is responsible for inducing itself, for inducing EMF or current in itself. So this is called this EMF that we get. No, this is also known as self-induced EMF. Self-induced EMF, or you can also sometimes hear this term back EMF. This term is also used. Back EMF. So back EMF means what? Back EMF, self-induced EMF. These are all the same words to refer that whenever the magnetic field will increase or the magnetic field will decrease, there will be an associated EMF. Till here we had studied it in the laws of EMI already itself. But here what is the case? That in this coil only it got induced. That's why the term self is mentioned here. Within the same coil, magnetic flux is changing. Within that same coil only, EMF is generating. So yes, definition I've already written. Self-induction is a phenomena of production of induced EMF in a coil when a changing current passes through it. As the current will change, magnetic flux will change, EMF will be induced, but this is about in a coil, means within the same coil all these things are referred. That's why we use the term self-induction. See, there are two examples. Let's discuss these examples, then it will become clearer. See, look at this first figure. In this figure, what is happening? If you look at this figure, this shows a battery and a tapping switch. This is a battery, this is a tapping switch, and this is connected in series with a coil. Coil is what? Coil is normally your solenoid, insulated wires which are wound in the form of or wrapped in the form of wires, circular form. Fine. So tapping key and all these are connected in series. So as the switch is closed, closing switch is this. So as the switch is closed, the current here, what happens? It will increase. Initially, the current was 0. When the circuit was open, there was no current flowing, so current was 0. When you switch the close, slowly, and slowly, the current will reach its maximum value. So from 0 to maximum value, the current will reach. Why? Now current increases because suddenly now the switch has been closed. So current increases from 0 to maximum value, and there is flow of induced current as well as in the circuit. What will happen? Current increases, magnetic flux in the circuit increases. There is associated EMF that is known as back EMF. Opposite thing will happen. Suppose induced current, and yes, induced current direction becomes opposite to that of the direction of the main coil, that we have already studied also. Because of Lenz's law, it has to oppose it. So direction of induced current is opposite. See, was the direction of the main current, and this is the opposite direction of induced current. That we have done through Lenz's law only, that you can revise from Lenz's law. Now if you open the switch from a closed circuit, if you open the switch, what will happen? Current was at its maximum value right now. Current was there in the circuit. Now the current's value slowly, and slowly it will ultimately become 0. 0 from the maximum value, it will become back to 0 because now the circuit is open. There's a break in your circuit. So if there's a break in your circuit, no current will flow completely. Here also, this is a battery. So here what is happening? Current is decreasing, flux is decreasing, again there is EMF. So these two experiments were just done to prove that whenever there is a change in flux, change in current, EMF gets induced. But can you notice this is happening within the same coil? Because you switched off the key, EMF got induced. Why? Reasons we have discussed. Same thing, when you opened the key, the current decreased and the EMF got induced. And this is occurring within the same coil only. That's why we call this phenomena as what? Self-induction. Self term is important. Induction means to induce EMF, to generate EMF or alternating current. So induced term is enough by itself. Okay, can anybody tell me, if flux is here and current is here, what is the relation between flux and current? How are they related? Directly proportional, inversely proportional, totally independent of each other? What do you think about the flux? Right now I've discussed with you so many points. Flux, whether it's directly proportional, current and flux are directly proportional to each other, inversely proportional, directly proportional. Yes, good Asta. See, flux, as the flux increased, current increased. As the flux decreased, current got decreased in the circuit. So this shows what? Your flux is directly proportional to the current. Now, if the current here, this is directly proportional, what do we do to remove the sign of proportionality? We put an equal to with a constant. Here, the constant that you will obtain, this is known as coefficient of self-induction, or this is also known as self-inductance. Only self-inductance also you can call this self-inductance. So if you substitute current as 1 amperes, so flux will directly be equal to self-inductance. So you can define self-inductance as what? It's the flux that is flowing per unit, for current passing through per unit area. Or you can say self-inductance of a coil is numerically equal to the flux. Both are numerically equal within the coil with a unit current when a unit current flows through that. Fine. Now, even if you put the formula E is equal to minus L di over, okay, we haven't discussed this. Let's discuss this. Fine, so flux's value we have obtained. Now EMF's value, remember we had EMF's value. E was equal to what? Minus d phi over dt. From here, if you keep the value of self-inductance, L, then what do you get? dl I over dt. L is a constant, so minus L comes out. You are left with di over dt, rate of change of current. So inductance can also be written as 1 voltage or 1 volt for 1 unit rate of current. That is also correct, or you can even define it like this also. See, I have written this statement. Self-inductance is what? Self-inductance is numerically equal to the magnetic flux when a unit current flows through it in 1 second. Because when you put everything as zero, what are you left with? That current, and both become equal to zero, self-inductance. Now, SI unit, regarding the SI unit, see, inductance is what? Self-inductance is 1 volt if you write for EMF, and this was di over dt. So 1 ampere by 1 seconds. Fine, 1 ampere by 1 seconds. All this is equal to 1 Henry. So H, capital H is the SI unit of Henry. For both, one more type of induction we'll do. There are two types of induction. One is self-induction, other is mutual induction. Self-inductance, we are studying self-induction. So see, understand self-induction clearly, because in mutual induction, nothing new will come. It is just that you will be having not a single coil, more than a single coil you will be having. That's why. The rest of the things remain the same. So self-inductance is numerically equal to magnetic flux. Right? L is equal to 1 Henry. SI unit of L is 1 Henry. Even if you wish, you can write the dimensions also. If you wish, you can write the dimensions also of this. Dimensions you can calculate from here. See, L will be equal to flux divided by current, and flux you can write it as BA divided by current. So from here you can get the dimensions, but asking the dimensions in your board exams is very rare. I haven't seen any question till now in your board exam that come. All those students who are preparing for their entrances, for them this becomes very important. For students who are just going to appear for their class 12 board exams, for you all dimensions, learning dimensions is not that very important. Let me just brief you with what we have studied till now. Otherwise, it will become confusing. See, self-induction is what? Whenever magnetic flux linked with a circuit changes. So there is production of induced EMF within the same coil. So we call this as self-induction, because the same coil has changed the EMF. Sorry, the same coil has induced, changed the magnetic flux and has induced the EMF within itself. That's why we call this phenomena as self-induction. Then we had seen two experiments. If you have the closing switch, then current increases, flux increases, again there is EMF. And when the opening switch is done, opening of the switch is done from closing position, then current decreases, flux decreases, again there is EMF production. We have noticed that current is always directly proportional to magnetic flux. If it increases, it increases. If it decreases, it decreases. So flux is directly proportional to current. From here, you can say magnetic flux is Li. I is what? I is current in the coil. And flux is what? This is magnetic. This is magnetic flux. So phi is equal to Li is one of the very important formulas for you all. And this more than phi is equal to Li, this is a very important formula. This formula, this is very important. E is equal to minus L di over dt. And from here, you can even equate it. You can numerically prove that, see, if di over dt somehow becomes equal to 1 ampere per second, then L will be equal to EMF only. That's what has been written. Self-inductance is numerically equal to magnetic flux when a unit current flows through it. SI unit is Henry and dimensions are this. Tell me, is it clear till here to all of you?
Yes, ma'am.
Oh,
Yes, ma'am. Clear.
all right, good. Note it down till here. Then one more small topic is then we'll move on to mutual induction. Done class till here?
Almost last one. After at the time.
Okay. Take 2 minutes and just text me done in the chat column. And if you all have any queries from this, please let me know. One small topic we have, self-inductance of a long solenoid. That also comes in your exams. All right, if you all have completed, then let's start. If anybody is writing, just stop me then. I'll scroll back. Self-inductance of a long solenoid. So what was the magnetic field for a solenoid? We have done magnetic effects of electric current. There was a formula specifically for toroid and solenoid when we did applications of Ampere's circuit law. So what was the formula of magnetic field for a long solenoid? Yes, class.
Mu naught Ni.
Yes, Asta, good. It is B is equal to mu naught Ni. See, for a toroid, this small n becomes number of turns per unit length, that is the circumference of a circle, n by 2 pi r. And for a long solenoid, it becomes number of turns, which is equal to n by L, that is number of turns per unit. Now, magnetic flux is what? Magnetic flux is B dot A, BA cos theta we have done. So that is magnetic field multiplied by the area. So keep the value of this flux. Flux becomes equal to mu naught Ni A. Fine, till here. Now see that this is just the magnetic flux linked with a single turn. If I talk about magnetic flux linked with the entire solenoid, then I obviously have to multiply flux linked with each turn by the number of turns. So what are the total number of turns present? See, if small n is equal to capital N multiplied by n, from here capital number of turns is equal to n into capital L. From here just cross multiplication, right? This is what? This is number of turns. This is length. So this becomes number of turns per unit length. For a toroid, it was 2 pi r. Just a reminder for all those who have forgotten. So magnetic flux linked with each solenoid the entire solenoid will be equal to flux for each turn multiplied by the total number of turns. If you know flux for this turn, then you can easily predict for the entire solenoid. So flux linked with each turn, this is what? This is mu naught Nia. Right now we have done, a number of turns will be small n into capital A. So this becomes what? This becomes equal to mu naught n square I A. All right, this is equal to flux. Also, we have done flux is equal to Li. Right now only we have seen this formula that flux is equal to Li, inductance into the current. So equate both of these equations. Both of these equations are giving you flux only. If I say, if you equate equation 1 and 2, see mu naught n square Ia will be equal to L into I gets cancelled. Self-inductance formula becomes mu naught n square A. One more thing, if you want to write it in terms of capital N and L, so you can write it as mu naught capital N square A by L. This is the entire formula for self-inductance of a long solenoid. Fine, quickly note it down, then one numerical we'll discuss. So I think these steps are easy. Magnetic field, then flux for entire solenoid, equate it with Li, you will get your answer from here. So easy steps are there, and this question comes in your exam. And do mark this as important. Whenever you write, wherever you write the heading, mark this as important.
Last, I just roll over. Done.
Ma'am, done.
All of you have completed?
Yes, Nanda.
Okay, let's just practice one numerical first on this. See, this question says that a 12-volt battery is connected to a 6 ohm resistor, 10 Henry. Fine, 12 volt is the battery, 10 Henry is the inductance, 6 ohm is the resistance. And a constant current is flowing through the circuit. Now, the total time that is taken is 1 milliseconds to open the switch. See all the data that is given. A 12-volt battery connected to a 6 ohm 10 Henry coil through a switch devices a constant current through the circuit. So the switch is suddenly opened. If it takes 1 milliseconds to open the switch, find the average EMF induced across the coil. So average EMF formula is D minus L di over dt. Now, do we have all the sufficient information? Average EMF, we have to calculate. Inductance, yes, we have inductance. We have time, yes, we have time. But do we have the current? We do not have the current. Rather, we have the voltage and the resistance. From here, we will be able to calculate the value of current. Current will be equal to V divided by R, that is 12 by 6, which is equal to 2 amperes. Fine. Now see, this is 2 amperes and time is given as 1 milliseconds. So di over dt, the change in current by change in time, this becomes 2 by 10 to the power 1 milliseconds is given. No, so directly let's write it. So this is di over dt. So final current will be 0 because it has written that the switch is suddenly opened. So when we have discussed both the cases, if switch is suddenly opened, what will happen? The whole entire current will become 0. So final current is 0. So this becomes 0 minus 2. Here you have 0 minus 2 and this is 1 milliseconds. So this becomes what? This becomes minus 2 into 10 to the power minus 3 amperes per second. Fine. This is your di over dt. Now, if we have di over dt, we already have inductance as 10. So average EMF will be what? Put it here. This becomes minus L is 10 and di over dt is minus 2 into 10 to the power minus 3. So this becomes 2, positive 2, 20,000 you can directly say. This is 20,000 volt. This is the value of EMF. 20,000 volt is the direct value. So current you can calculate from voltage and resistance, and inductance value is given as 10 Henry. So from there you can calculate the value of EMF. Fine. Mutual induction, let's start, but before that you note down this. Any part of the question you have not understood, let me know. This is a direct question based on EMF.
Ma'am,
Yes, Anushka.
ma'am, just want to confirm that today's class is till 7 o'clock as well, till 8 o'clock as well, right?
Yes, yes. Today is still 1.5
Yes.
hours only. So Anushka, your unit tests will be over by are these your unit tests or half yearlies?
Ma'am, the one that I mentioned, it was just simple class tests, but then our half yearly will be starting from 7th November.
November, your half yearlies. Okay. So UTs are over?
Yes, ma'am.
All right. So half yearly in November. So when do you all have your pre-boards? Usually in the month of December or Jan?
Yes, ma'am. Probably December.
December.
Because
Asta,
our
what
school
about
is
you?
saying that the
Ma'am,
practical exams will
November
be in
last
January.
week they'll start. They said the pre-books.
Pre-boards will start from
November end or like between. I guess
November.
November 17 something. I think it's starting.
Okay, okay. And yes, Anushka, what were you saying?
Ma'am, I was saying for us, probably we'll have in December month, and from January we'll have our from January first week or something we'll have our practical exam.
Okay, okay, okay. And what about others? Do you also have any idea about your pre-boards? Because we have to have the revision classes as well. See, now only after alternating current, you will have optics left majorly. Rest of the lessons are very small lessons in one class. EM waves will get over in just a single class. So alternating current is not very huge, but it requires a lot of concept. Otherwise, your major topic is ray optics. Now the chapters are very small. That's why I wanted to ask. So if others also, Imad, Razan, Mariam, you have any idea about your pre-boards, to let me know. Accordingly, we'll do it. Imad, you were saying something?
No, ma'am. No.
Okay.
Ma'am,
Yes, Asta.
ma'am, today's class is 2 hours or 1.5?
1.5. Today is 1.5. I'll inform you people if we have 2 hours class. No, because I think next weekend, I'll inform you tomorrow. When we have the test, we'll have a class of 2 hours. So half an hour will be your test. Because C class, your time duration is 1.5 hours, and in this we have to cover now AC. Your first book is also not completed. So at least by now the first book should have been over. If we require for any of the topics, we can have a 2 hour class. Yes, Imad.
Sorry, I'm just going through this question. Can you just explain this, ma'am?
This question?
Yes, ma'am.
Okay, yes. See, this question says what? The question simply says us that current is there, and current, what is happening to the current? The value of current is decreasing. Why? Because it has written that current, the switch is open. So if you open the switch, the circuit breaks, it means current will be now 0. So change in current will be what? Change in current will be simply 0 minus 2, right? 0 minus 2. And why do we have 2? Voltage is given, resistance is given. From this, we have calculated the initial current, and final current is 0. So I final minus I initial will be 0 minus 2. Time is 1 milliseconds already, right? So this is di over dt. L is given to us as 10. So 10 multiplied by di over dt. And minus sign we have here, so minus into minus becomes plus. Understood?
Yes, sir.
Okay. When you all will write it down, please text me done in the chat room so that we can start with mutual induction. Now, if you have understood self-induction very well, if you have any queries from self-induction, you can ask me, because mutual induction is similar, just similar to self-induction. C class, mutual induction is now understanding mutual induction. This is very easy. What we have discussed in self-induction, within the same coil, current got changed, magnetic flux got changed, and so there was induction and production of EMF. Now here what will happen? Current and flux will change in one coil, and induction of EMF will other coil. That's why we say mutual induction, which involves more than a single coil. That was self, because it was occurring within the same coil. This is mutual. 2 coils are required. You call this primary, and the other one is known as secondary. This is what is the basic meaning of mutual induction. So rest of the things will be similar to it. So mutual induction is what? Here in the primary coil, there will be the increase or decrease in the current, fine? Or you can say the flux will increase or decrease. But EMF, which is known as the back EMF or induced EMF, this will get induced in the other coil. So the coil which can be regulated, we have all this rheostat and key and battery connected so that we can alter the value of current and the magnetic flux. And here just galvanometer is present to detect alternating EMF and alternating current that is generated because of the induction. And the coil where the manipulation of currents, magnitude and flux is done, that coil is known as the primary coil. And where you see the effect of EMF, where the induced EMF is produced, that neighboring coil is called the secondary coil. So this is not difficult to learn. This is easier to remember. It's easy. Fine. So in the primary coil, there will be a decrease or increase in the flux depending upon the key. If you close the circuit, there will be increment in the circuit, increment in the current, because from zero a maximum value will be reached. So all the phenomena are similar or related to increment in the current will occur. See, if you close the switch, current will increase, flux will increase, EMF will be induced. If you open the switch, current will decrease, flux will decrease, again EMF will be induced. But it's just that since two coils, primary and secondary, are involved in the production of EMF and the current through it, which is deflected, which is seen by the deflection in the galvanometer, this coil, P coil, is called as the primary coil and this S coil is called as the secondary coil, because it is the one which causes an induced EMF. See, this causes induced EMF in this. Simple. If you say this primary coil causes induced EMF in the secondary coil. All right. Now see, things will become similar. Here also you will be having, definition is there. It is the production of induced EMF in one coil due to change of current in the neighboring coil. Understood? Phenomena of production of induced EMF in one coil due to change in the current in the neighboring coil, change of current in the neighboring coil. The coil that is present beside gets induced. See, things will be same here. Flux is directly proportional to the current, but here you will be having the constant which will be called as M, coefficient of mutual induction, or this is known as mutual inductance. The way you had phi is equal to Li. See class, EMI was a very short lesson. See, I think this is the third class and our chapter is already over. So this is a short chapter, revise it well, you'll be able to do it. The important topics from EMI include this induction only. First thing, induction and your Lenz law. These two things are very important. And if sometimes we have to remember certain things, no, the maximum important portions for a lesson whenever we revise. So this is induction and Lenz law. This becomes very important, very important. So this is similar also. Phi is equal to Li was there. Now you have phi is equal to Mi. So this much you can see. Similarly, if you keep it in the formula, E is equal to d phi over dt, you will get the same thing, minus M di over dt. Understood? Instead of L, you are getting M. L was self-inductance. This is mutual inductance. And again, you have the SI unit Henry. So there is no distinguishable SI unit for it. There is no specific distinguishable SI unit for it. And see, even if you see M from here, see how is this M written? E is, let's ignore this minus sign, di over dt. So from here, M can be written as E divided by this whole term, di over dt. That's what I have written here. Now see, mutual induction can be written as what? EMF is 1 volt. This is 1 ampere per second. So 1 ampere per second, this becomes 1 volt seconds ampere inverse, or this is again your Henry. This is the definition of 1 Henry. Same things, class, same thing. So how can you say what is the meaning of 1 Henry? Mutual induction of two coils is said to be when 1 Henry when the induced EMF of 1 volt, induced EMF of 1 volt is set up in one coil when the current in neighboring coil changes by 1 ampere per second. Or you can say rate of change of current. This term, no, di over dt, you can simply call this as rate of change of current. Rate of change of current. Simply rate of change of current. Now here also long solenoids we have. For long solenoids, let's do it together only. Then afterwards you can note it down. See, mutual induction of two long solenoids. Here, what will happen? A single solenoid will not do your work. Why? Because mutual induction is there. So obviously, a single coil cannot produce any of the effects that we have studied for mutual inductance. For mutual inductance, you require coils. For self-induction, we had a sufficient one coil enough for itself because the current also changed within the same, flux also changed within the same, and EMF got induced within the same. Here you have two coils. So neighboring coils are present. So there can be change in the mutual inductance. So see, this coil I have taken, drawn with this orange color. I1 current is flowing through this. N1 is the number of turns in this first one. And let's say radius of one of the coils, the circular part of the coil, no, this part. This is R1. And then I have taken one more coil, that is this blue colored coil. Here I2 current is flowing. Radius is R2, number of turns is N2. So R1 is the radius of coil 1, R2 is radius of coil 2, I1 is current in coil 1, I2 is current in coil 2. Length of the solenoid is same for both the solenoid that I have taken. The length is same, and you also will be taking the same lengthened solenoids. N1 is the number of turns in coil 1 and N2 is the number of turns in second coil. Dimensions I have written. Now see, here one or two things you have to remember that can become tricky to understand. Otherwise, see, a slight difference will come here. Till here, rest of the things were similar to what you've studied for mutual self-inductance. Now a difference will come. See what the difference will come. Flux 1, magnetic flux in the first coil. This will be due to magnetic field in the second coil, because this is mutual induction. So even if the flux is there in the first coil, why is the flux there in the first coil? Because of generation or change in the magnetic field of the second one. So B2 mu naught Ni you can complete. You can write this as, or instead of writing mu naught Ni, this is the formula of magnetic field. No. See, flux is what? Flux is B into area, magnetic field into area. Phi is equal to BA. So B is B2. Area you can write it as A. And for number of turns for this flux, you can multiply it by N1. But more importantly, and main important thing is B2. See, B2 is mu naught Ni. We all have revised this. So this will be N2 and I2 because this is only for the second magnetic field. This you have understood. Why are we writing B2 here and not B1? This is phi 1. This is N1. This is area. Area 1 also, by the way. Area 1 will be included. No, we are referring to the area 1. Or you can even keep it like area. Area, then you can substitute. At the end, you can substitute which area you were referring to. But since the mutual induction is present, magnetic field is changing in the other coil. So I'm writing it as B2. Now let me put the formula complete together. This becomes mu naught into, this becomes I1 into A into N1. Now, coming to this mutual induction of the first coil with respect to second. M12 means mutual induction of first coil with respect to second. It means flux is changed in the first coil and current is induced in the second coil. This is what? This is mutual induction of first coil. So the magnetic flux has been changed in the first coil. That's why phi 1. And the current has been induced in the second coil. That's why I2. Now, if I combine all these from there, if I write the magnetic formula of flux, see, II will get cancelled. I2 and that I, both the currents will get cancelled because the currents were same. But I can write this as mu naught N1 N2A by. Maximally, the questions come from self-induction of long solenoid. But it can happen that mutual induction can also be given to you. Fine. See, same thing if you have to calculate for B1. Let's say if this is I have calculated with respect to the second one. No, if I have to reverse, if I want to calculate the second due to the first, mutual induction of the second due to the first. See, the story will be same. This becomes B is equal to mu naught N1 I1. Phi will become equal to this phi2 will become equal to B1 AN2. And rest of the story will keep on repeating itself. So mu naught N1 I1 AN2 and so on. Same story will repeat itself. So what will you get? Instead of M12, this time you will be having M21. M21 is what? Mutual induction of second coil with respect to first one. This is the formula, mutual induction of second coil with respect to the first one. So same thing, see, result will be the same because you will write here phi, this will become opposite, this will become phi 2 by I1 because flux will change in second, phi 2 by I1. But result will be the same. This will be mu naught N1, N2, A by L. Even if you've checked or cross-check, this derivation comes same. So here you can say, you can state this fact. See, one thing you can state that mutual induction of first with respect to second or second with respect to first. Both are equal to each other in magnitude. And a conclusion and a final formula, if you want to write, you can write mu naught N1 N2 A divided by L. Now, whichever will have the current enclosed and will be lying within the coil, that area you will consider, be it first or second, depending on your needs. So this can also be written as mu naught N1 into area into L. And class, wherever required, substitute area as pi r square, wherever in any of the cases you get this. So whenever you see, just mark it as what? Pi r square around whatever area is required. One more thing, you have coefficient of coupling. This is also small and easy. See, coefficient of coupling is simply a formula that unites your self-inductance and the mutual inductance. This means, for example, I have, let's say 2 coils I have. So if I have 2 coils, will there be phenomena of mutual inductance or self-inductance according to you all? 2 coils are there. Yes, class, 2 coils are there. So there should be mutual induction or self-induction.
Ma'am, mutual induction.
Mutual induction. Good. See, 2 coils are there. There will be mutual induction. Yes, Razan. But one more thing, class. It can also happen, no, that mutual induction is occurring because of these 2 coils. But if you look at this coil only by itself, then there can be self-induction within this coil also. Let's say the entire mutual induction is M. But it is also possible, no, the self-induction of this side is L1 and this is L2. So to unite all these 3, you have a coefficient of coupling, which is written as M by under root L1 into L2. Class, this question is, this coefficient of coupling is asked very less in your exams. Asking frequency is very less. From induction, you have mutual and self-induction, the solenoid part as well. But coefficient coupling is asked a little less. Fine. And also remember, this value lies between 0 and 1. These are just some extra things for you, coefficient of coupling especially. But this was easy, you all can remember. Fine. Just do one thing. We have discussed a bunch of this. Start noting from here. Wherever you're not able to understand, let me know. As you'll keep on completing this, you all can leave. This is all about today. Already your 5 minutes have been exceeded. So just text me done and then you all can leave. Okay, Maria. Thank you so much.
Ma'am,
Yes, Asta.
ma'am, what does the K represent in
K
this
is
form?
just a constant term, just a constant term. So this value is for different coils, different medium. The value differs between 0 and 1, 0.5, 0.3, all these kinds of values. But this is for you. You just remember that this is just a constant that relates your M, L, L1 and L2 basically, if you have more than 2 coils present. Because within the coils also self-induction will occur, and 2 coils are there, so mutual induction will also occur. So it's just known as, we refer to this as coupling because 2 coils are there. So coefficient of coupling, do no need to go into the details. And I'm